All right. So our speaker this week is Chuck Wilson, who has a company in deep stealth, performing document management and document classification. Chuck, thank you so much for being here today.
Absolutely.
Chuck is also a co-organizer at the Swamp, so he had to do this. Tell me a little bit. Are you originally from this area or surrounding areas?
From the triad of North Carolina.
North Carolina.
So Greensboro, High Point area.
Well, it's been good having you. I mean, I hope it's a nice trip. Cool. So what brought you originally down into Columbia?
First job.
First job, which was?
I worked at a large insurance software company called Policy Management Systems Corporation. It was the first insurtech anywhere and the largest in the world that happened to be founded in Columbia, South Carolina.
Very cool. And I think the founder has the same or a similar last name as you, but no relation.
Just passed away, but Larry Wilson was the founder. He got a start at Siebel's Bruce, which is an insurance company here in town, while he was in college. Started software when nobody knew about software, and then that led to a billion-dollar company that he created.
Little thing.
So
how did you originally kind of get into tech? Like, what brought you into the space?
Yeah, good question. Just early age, 3rd grade, 4th grade, there's a computer. Nobody knew how to work it. Started playing with a computer, and ever since then.
Ever since. And so you've had a kind of you're a really humble guy, but you've had like a really cool career as well. Like you worked at this early stage, essentially very early unicorn, right? Yep. But you've also had some ventures yourself that have been successfully exited as well.
Yep. After working at Policy Management Systems, I spent about 5 years there. And through those 5 years, really got an itch to try to start something once I understood how a company worked. And I was fortunate at that company where ended up being kind of at the bottom, entry-level developer, just learning the ropes. But my role was such that I got exposure to all sorts of parts of the company. So I was in a small group, very niche technology, that there weren't many people that knew it. And so I ended up doing development, doing implementations with customers around the world, helping on sales, presentations, marketing support. So I got exposure really to the full life cycle of how you build software and actually deploy it and use it.
I know personally, I think the most important thing in a tech startup is tech, right? That's not everybody's opinion. And I know some startups are, tech startups that are heavy on the tech and some are light, but where do you feel for the things that have helped you be, I would say a quite above average founder, right? Several successful exits. You've survived this, to have like, I think this is like the 3rd venture you're on, and still be interested. But how important do you think tech is in the marriage of business and relationships?
Different than when I started. At first, I might have shared your opinion that it's all about the technology.
Yeah.
Until I saw when you dig into the technology of some of the companies that are out there and how poor the technology is, but how successful they are as a company. And so that changed my impression. But I still have the bias to a nice, strong technology-focused product. Mm-hmm. But I don't discount the importance of sales and marketing to help position it, as well as the delivery of the product getting to the market.
So for those of us like myself, and you're always very kind and like giving me advice, which I appreciate because I'm really just fumbling around in the woods with my startup. What do you think is important for like maybe young first-time technical founders to keep in mind?
I think first is you can build the coolest product ever and do all the cool things.
God, I'm going to be a unicorn. I'm crushing it.
If nobody's going to know about it. So to me, it's the balance. Mm-hmm. How do you get, 1, a product that compels people to use it? And then 2, how do you build upon that usage of the product so more people know about it so you can add customers to add to your revenue?
Awesome. That's really cool. I'll ask you kind of like another question that I think is going to become like our similar question. I know you're in tech and you're doing tech, but whether it's tech that you're currently involved in or not, is there any tech out there or developments that's happening that you're really excited about?
I'm a loser. All of it's interesting to me, quite honestly. If it's something I don't understand and there's something with technology, I'm reading, watching videos. I'm trying to learn about it. And the idea for me is much like I try to spend a lot of time reading books or about things that are outside of the technology itself. And what I regularly find is many an idea is spurred by other technology, other things that you can apply directly to business problems that you're working on with your own technology.
Very cool. So what is the talk today about a little bit, high level?
We're going to talk a little bit of the work that we're doing, and it's around really document processing, and in particular, being able to classify and extract data from documents.
All right. Ladies and gentlemen, give us a round of applause. Chuck Wilson, show is yours. Gonna do what I do best and make too much noise. Get you some water.
I've got some time.
You got some? Oh,
yep.
Thank you. Just gonna steal my Diet Coke back. No, perfect.
Oh, it's not.
Carl's stuck having to use my terrible laptop, so he's being a really good sport.
We're all learning. Speaking of learning new, right? That's what I was hoping.
No, you just have less homework. That's all that changed.
You just have to work here.
Yeah. The hard part about this is the streaming. I've added a lot of layers to this because this is obviously Carl can easily get something like just a presentation, but we have to also make sure that it goes to the YouTube for both of for David. I think David might be the only person watching it this week.
I think it's good for. Yes, it's great if I can figure it out. Unless you want to keep your stuff. Where are any of the previous teachers?
Don't be shaming her. She's
No peer pressure. This is a safe space.
There we go. That'll work. When it all else fails, it's kind of like reboot, but.
Oh, was the clicker was our downfall this whole time?
which way?
Yeah, that way.
Okay. Alrighty. So again, document management, document processing. Going to talk a little bit about the work that we've been doing and how we've approached things. Feel free to jump in with any questions, as Tad mentioned. Happy to answer them as we go and see how we go. So the idea behind this, a model's dream, it's a story of an AI model and its aspirations. Are you sure?
Well, except when I keep messing with the stuff and then it changes the thing. Except for that, yes, I am absolutely sure. Okay, there we go. See, well, for our streaming friends, I actually have to visible, and that was not the case. So thank you, streaming friends. And if I get that's not correct.
Awesome. So this is based on a true story. I will offer up that aspects of the story have been fictionalized, and we've changed some names just to protect the innocent, like most cases. So, as any story, starts with once upon a time. And we introduce you to the main character. It's Gizmo Bunt. Gizmo happens to be a young, inexperienced, swamp-dwelling AI model. Very much looking for his next opportunity and really thinking about just needs a break. He's looked and looked, has all his skills, just can't find a break. Fortunately, just across town, we've got Old Fashioned Inc. Old Fashioned Inc.'s a middle-aged software company. Maybe stuck in its ways. The good thing about it, though, recognizes that it might not be doing the things it should be doing and is looking for help. And as it's offering that help, what it decides to do is work with its customers here. They're obviously complaining that they need help. They're tired of doing things manually with the documents. So if you can imagine the customers for probably 25 years, they're asking their customers to manually scan documents, take those documents, decide what type of document it is, manually key information of those documents into other systems that they need to work with. And these customers are smart. They've been watching the news. They've been hearing things. There's lots of ways to improve that, to start pulling that information out and away from those documents automatically. And so with that, they're pushing for a change. The way they go about it is they offer up a help wanted ad in the newspaper, specifically asking about a document classification and extraction model. Gizmo, super excited. I don't quite know why he's also in the help wanted ad, but that's okay. Maybe very targeted ads we have going here. But Gizmo sees that, man, my big break's here. Here's the opportunity. Applies for the job, and congratulations. He wins the opportunity to test his mettle with the contract itself. So he's off and running, thinking about it. Unfortunately, that excitement is a bit short-lived. And like many of you, you're looking for your big chance. You get that chance. You might not be completely confident of whatever you signed up for that you're going to be able to do that. That's the case with Gizmo as he starts out. So he starts thinking about what in the world is going on. I don't know for sure that I'm going to be able to do this. This company is depending on me to be able to satisfy this. So quickly, gosh, I don't know what I'm doing. I've never done this before. So part of that, what really made him nervous was he's got to create these models. And in particular with the models themselves, a goal of any good model, and many in here that have experience with AI will speak to it, you need a very diverse data set. It needs to be well distributed and very well representative of the types of data that you may see in a production environment. So people using the system. And you're going to train that model based on that data. But one of the problems is, how do you choose what documents that you're going to use for this particular process? And so in particular, documents, they come in all shapes and forms. Old-fashioned Inc. has very specific documents that their customers use. So how are we going to work through this? And so old-fashioned Inc., they've been in business forever. They have hundreds and hundreds of customers. They have repositories of documents that are great representatives of the documents that you might deal with. But there's so many that you need to choose from. And there's so many document types. And you can think of document types as we're talking about here, or things like this is an invoice. This is a credit card statement. This is a W-2. This is a application. So all these types of documents that are out there. And these customers have literally millions of documents. And each customer of the hundreds have millions of documents to work with. So how do you build models that could work for all these customers where you have such a distributed data set that you have to work with? So Gizmo, just as despair was there, how am I going to do this? He gets inspired, has a great idea. He's going to work with these documents, a very structured process that he's feeling really good about. His first idea is to organize the document types by type. So give me all the invoices, give me all the driver's license pictures, the credit card statements, and I'm going to group those as, say, type 4 are invoices. And if you think about that, invoices themselves come from lots of different companies, and while you as a person can look at it and say, this is clearly invoice, it looks very different, and for a machine to understand that, or an AI model like Gizmo, very challenging to work that out. And so his second step in his thinking was, first I'm going to take document type 4, so let's say these are all the invoices. I'm going to group these invoices together, and then I'm going to split them out by type. This is from one organization, this is from another company, and start grouping them together to where he has a nice split of all the document types themselves. So you get a good idea of what invoices look like that their customers are dealing with. And keep in mind, while this is a simple set of 9 documents that we're sorting, we're talking millions and millions, hundreds of millions of documents that we have to start with to try to figure this out. And so the next step in the process is really taking these group documents, and again, we want the variety, so a diverse set, as well as a well-distributed set of data that we're going to work with. And so we end up with really taking one of each of the 4 types that we've identified of this particular document type of invoices. So with that, I'll pause just a little bit and out of story. Are there any questions, or does this all kind of make sense? And are you in line with, we're talking, say, invoices, we're looking at variations of invoices, and we're trying to take a sampling of each individual type of invoice that you may have run across? Or any questions with that?
I just think in general, because I mean, it's obviously a difficult problem. What is, from the customer standpoint, what is their expectation of accuracy? Like, how good do you have to be good?
Yeah, so the nice thing about this, really what you're trying to do, so you're comparing it to what they're doing now, and it's manual entry. And so in manual entry, doing lots of keying, lots of processing, as long as it's better in improving the process than manual, you've improved. Now, if you're getting lots of things wrong and having them rekey or reset, and it starts causing really user friction is really what you're worried about from a UX standpoint. Is somebody going to start complaining about, man, it's always wrong, I have to rekey this, or I have to remove data? So it's not like we're trying to decide whether this cell is cancerous or not, where you better be very accurate. We have a little bit more tolerance here, but the tolerance is really more user aspect than the actual accuracy itself. So this is a balance there that you're working.
And I guess there's several avenues of success. Like if you were at, almost as good as a manual entry, but 100 times faster, then that would probably be considered a plus.
Yep.
If you were more accurate, that would be a plus. So there's several avenues to like kind of build this as a successful model.
You've got it exactly right. And I will say, like a lot of companies, and you saw the rush right after all the ChatGPT or LLM models came out, there's probably not a software company in the world that on their roadmap or what they've released, they've tried to figure out a way to shoehorn LLMs in. And really it's to pick up on the momentum or the expectations of customers. For old-fashioned ink in this particular situation, they are, in some respects from a sales and marketing perspective only, wanting to be able to say that they're doing AI as well. So again, Tad, where you were leading, is it technology-driven or is it business-driven? For them, while they're going to sell the product that we're putting together, they probably care less to begin with of the value it's providing to the customer as much as the marketing buzz and real chops behind it that they can support it. But the marketing buzz is probably going to carry them as much from a market opportunity. The customers themselves, they are looking for the advantages, certainly. But for old-fashioned ink, a lot of their motivation has been their investors saying, why aren't you doing something with AI? What can you do? Their customers starting to ask that. So the sales and marketing aspect is important. And our responsibility, Gizmo's responsibility, and the whole idea behind this is it's on him to make it work.
Right. Very cool.
So again, gosh, just as he thought he had a breakthrough, he starts thinking, well, this seems like it'll work. How am I going to do this? I don't know how to do that. On paper, it makes sense. If I was sorting them manually, I could do this. But I don't know the techniques that I could use to do this. And so just as this kind of jumps back, he happens to remember who he can use for help. And so it happens to be Lana and Hannah. And so he went to data science school with them, took classes together with them. Lana being a worldly technologist that knows everything, has lots of experience in the market, different customers, different technologies, and certainly data science. And her sidekick, Hannah, just happens to be a student, but very bright, very motivated, looking for opportunities, and just so happened to have started taking some of these classes to get refreshed with this. So between these two, maybe the perfect pair to help out. And so this immediately changes to kind of some reminders for Gizmo, where a bit of refresher back from when Gizmo was in school, learning the ins and outs of maybe some technology that could be used to solve the problem that he's brought to Lana and Hannah. And so with that, they started jumping into some statistical and machine learning concepts. And so the first is principal component analysis that they'll spend some time reviewing. Next up is k-means clustering and some of the techniques to help you understand how many clusters you might use through that particular process. And so as this goes on, Lana and Hannah lead the process. They introduce principal component analysis. And really the idea there is in a document like you have here as a sample document, you end up with so many dimensions. And the way you can think of this document, the dimensions are the width of the document times the height of the document times the color, so the red, blue, and green that's tied to that. And so if you're just looking at a document trying to see the difference, you end up with over 1 million dimensions or variables or factors that drive the decision process. And why principal component analysis is so important, it's a statistical technique that looks at all those dimensions and then figures out what are the most impactful when you're comparing data to data. And so it ends up creating essentially new variables from those dimensions that simplify the process altogether. So it really streamlines the process of how you're looking at this rather than having to work through that. And so a lot, and I'm sure Tad has plenty of examples and maybe others that have gone through this process. By removing the dimensions, one, you don't have to deal with as many attributes. In many cases, you get rid of a lot of the noise and the things that don't matter in your process that can be just where you're wasting lots of time. And then finally, even the storage of data. You can start with a big data set, and once you run it through this algorithm, you can really sort it and get a much smaller data set that goes with that. And so that's my layman's description, and probably can't go a whole lot deeper than that. But Lana went on and she was talking about linear algebra, things like covariance matrix computation, eigenvalue decomposition, eigenvalues, eigenvectors, scalars, all sorts of stuff. If you want to know more, Tad could probably do a class this afternoon. That's the post meeting, I think, that we're working through, where Tad jumps in and walks through.
Be like, what a nerd.
all the math associated with that. So after principal component analysis, and so what we've done is we've taken 1.5 million dimensions and we really reduced it to a smaller set. And then that allows us to use the next technology or approach, which is an unsupervised machine learning algorithm that allows us to do clustering. And so when you're creating a cluster, you're essentially picking points on a grid, selecting items, and then placing your data points, all your data points on that grid that you've pulled. And so then you work through the process. That single point that you picked to begin with, you start measuring how far it is away from the different data points. And then you just keep on repeating this. And through the magic of this algorithm, you end up with a nice cluster diagram that starts grouping things that are like in one way or another. And in some cases, it's a mystery to why it's grouping depending on your data sets. How did it know to group this and that? And then through the principal component analysis, you don't even know why it picked what it did to make those differences. So it's a bit, in some sense, of a black box on how you ended up with. But it is a very nice technique that works well with images and many other types of data. So now with this background between the principal component analysis, the k-means clustering algorithms, we're back to Gizmo getting to work. So he started working through this, understands the concepts, and knows how to apply it to his data set. So with that, the first thing you need in any data science problem is lots of data. And so we'll highlight a simple data set that we have working here. It's about a little over 80 documents that we're looking at on the screen here. Each of these documents, if you just look at them blindly, there are certainly some characteristics tied to these documents that make them look different. So if you were a person, you could sit down with these 80 documents and you could sort them into different piles and end up with all the like-looking documents together. So that's what we're going to set forward doing. And we're going to do that using the cool technology that Lana and Hannah worked with Gizmo to understand. And so in this case, what we did is we created 50 on the x-axis principal components to understand ways we could visualize this data or work with this data or simplify the data that came off those documents. And then what we're looking for is what has the most impact in describing that data. So what are the biggest differences? And so what we can see, the principal components and the variance between 1 and 2 and maybe even 3 from the long tail that you see at 50, you can see that these first components have great variance. So that gives you a clue that this is the perfect way to look at this data. There's big variances, and you may, I mean, depending on the data set and problems you're solving, this may look completely different and may be less useful, and you might have to pull to other algorithms. But fortunately for documents, we're seeing great variance that we're seeing in the difference between the individual principal components that we've put together.
And I don't know to what level interpretability matters for your data, but have you done any analysis afterwards to try and figure out like what individual features sort of lead to, you know, like the collection of features in that like first component?
Yeah, for us, we haven't had to worry about it, and the reason is I was surprised that we weren't, and I thought we were going to have to get more sophisticated than we ended up. But as I'll walk through kind of the next, and I'll show you why what we were doing was good enough and it didn't require any more digging, at least what we found so far.
Cool.
So now that we have at least 2 principal components that we can work with that are much more varied than anything else, we're going to start working with those components. And we're going to use that to ultimately create our cluster that we're working with, a single 2-dimensional chart of the clusters themselves. And they can get way more complicated, but for our data set, very simple. But the question always is, how do I know the right number of clusters to work with? And there's a couple common algorithms, several. The 2 that we spent time with was the elbow method. And so it's very straightforward. Really, you're just looking for bends in the data where an elbow forms. And so in one case, this would tell you that maybe 2 clusters are the right amount. Or you could jump at 5 where it's bent a little bit, or even at 8 on the end there. That, again, it's not perfect. It is a way to describe a means to determine which clustering you might want to start with, how many clusters to start with as you're working with your data. Tad will be giving another talk here this evening afterwards to talk about what the within cluster sum of squares means and how that comes together. So stay tuned for that. The next is the silhouette method. So just another technique that you can use to help identify the number of clusters. And we really chose to run these 2 just to see the similarity between using these 2 different techniques. And so for us, what you're looking for in reading this is you're really looking for peaks. So where the other one, you were looking for really bends. In this, you're just looking for areas where things spike. And so for us, you know, starting at 2, but that's probably not going to be too valuable when you have as many different types of invoices that you might be aware of. Just splitting those in 2 is probably not going to be valuable. Starting to jump out at 5, 6, and even 8, which is interesting in that there's commonality between 8 here in the silhouette method as well as the elbow method. What's also maybe trending towards 8 might be the right amount.
We do have a question from our online community.
Nice.
Incredibly active. So on our Discord, Chuck Mastagrep has requested to know, documents seem like something you could create synthetic training data for fairly easily. There are tons of report generation tools, templates, etc. out there that you could fill your own fake data into. Could you discuss if there was any thoughts, you know, as you were collecting this original data set about using synthetic data, and whether you thought that was something you needed or not?
Yeah, to me, and there's probably lots of reasons, and you guys are probably much brighter than me to understand where you would and wouldn't. But to me, we didn't need certainly you could have done that, but from our case, our problem wasn't the lack of data, which is in many cases why you use synthetic data. You actually end up, we had the problem of too much data to work with to solve our problem. So other cases I've seen, and we did experiment early on by creating our own documents similar to that before old-fashioned ink gave us access to their data repositories, essentially. So for me, it was because we had too much data, not the need to generate data for it. But I certainly agree with documents are a good way, or a good example of how you could generate content from those. So now we've kind of zeroed in at least a couple number of clusters that we can work with. And so for us, we just randomly picked 5 to start with because that trended on one of them. And like a lot of data science projects, if you haven't worked towards them, it's so much experimentation. You try one way, see what it gives you, try another, and sometimes you try 2 different ways and hope that it gives you the same answer or not. If it doesn't, you better try a 3rd way to figure out what's going on until you kind of settle on, okay, I think I understand what's going on here. So with 5 clusters, here's our cluster diagram that we created. And so what you do see, which again, the magic of this unsupervised learning algorithm, is you see these nice groupings. But one of the problems with k-means clustering that can happen is it doesn't handle outliers very well. And so somehow it grouped purple with this. And so it's not necessarily a bad thing. You just have to recognize that even the red that you see, there's a grouping, and then there's 3 that are off to the side elsewhere. And so there's some experimentation here, but again, we're dealing with documents. The data is relatively easy and easy for us to visualize once we've done some clustering all together. And so that's what we've done. We've taken each cluster and started grouping together. So if you remember, we started in this example with 82 documents. Those 82 documents, in cluster 0, it found that it was going to group these together. And this is a little bit where, for us, we're fortunate because we can look at it and say, wow, that was pretty good. All these documents look like they're from the same company. They're bordered, they're bluish. They have a watermark right in the middle. So it did a magically good job of pulling together a cluster that matching documents. Yeah.
Some kind of OCR or image analysis first?
Yeah, so what we thought we might need to do, but in this case for us, we were really just trying to go by look and feel in this particular. So for us, it mattered less of the content of the document for this particular process that we were going through, less about the content of the document and more important kind of the look and feel of the document itself. Now there's some other problems that we do have to work with that we will be dealing with the content itself to be able to understand more about the sense of what's going on. And we've had some time with Tad and some of the work that his team's been doing of just understanding different techniques and what you can learn from pulling the documents themselves, including back to the statement from online, just being able to create synthetic data. Once you understand the data of a certain document, it's, I won't say trivial, but easier once you understand that these days to be able to generate new documents that are like the one that you saw to begin with. Yeah.
When was this?
I'm sorry?
How long ago was this? What was Gizmo working on this project?
Gizmo is actively working on it. We probably started working with Gizmo maybe late last year, I'll say. Yep. And so if we look at the next cluster, again, for some reason, the magic of the algorithm grouped together a bunch of documents. And you can see here, there's some interesting aspects of these. One, you'll see a lot of black and white documents, maybe a little color together. This document was blue and landscape. So there's some variation here that is pretty good, but I wouldn't say it was as slam dunk as the first cluster that we looked at where it grouped everything that was exactly alike. Next up, next cluster, again, magically taking out of those 82. It figured out that, man, these documents look alike. They have a border, they're colored, and grouped together. So magically that this came together. Yeah.
Yeah, so I said border right there. I mean, it looked more like, say, candies and also
In this case, I don't know how the principal component pulled it together, so maybe. It knows everything about an image. So it took the data, it had all the raw data. So essentially we created an array of all the pixels left and right, and it was 3-dimensional in that each pixel you saw on the screen is 3 deep, one for red, one for blue, one for green that made up the colors. And so that's all it had to work with. Now, so some of these techniques do a real good job at edge detection. So absolutely it could have picked up, hey, this has a really strong edge associated with this that are color, so it could have picked up on that as well. Yeah, you've got it, exactly. But see, the magic of this for us was we didn't have to do anything fancy. I mean, it was, I'm ChatGPT, hey, write me a script that looks at this and does PCA analysis and clustering with this. And there's a lot more brighter people that created all these libraries, one, that do all this, and then the magic of ChatGPT to be able to write the code for you. And we tweaked it, but I mean, it was the starting point. And a lot of these problems, once you understand the techniques these days, there's so much out there and so much help. Where when I started a long time ago, when I started playing around with this, first it was with neural networks before neural networks were cool, and you were writing everything from scratch. And then probably 10 years ago, I started, and TensorFlow and a lot of these libraries were not built, so you were writing your own neural networks from scratch. Now, there's a library for it. And again, some of it is just a black box. We thought we were going to have to do more, quite honestly, but so far, just using the simple techniques, we were able to align and just trust that it's doing whatever it needs to. And really, the way we were able to do this is visualize the data itself and understand, yeah, these documents look all right. That looks pretty good to me. Next up, did another good job, but one interesting thing that I see here is these look like cluster 1, or the first cluster that we looked at, a lot of the same documents. So somehow it grouped those together a little bit differently, but it did a good job of grouping those documents. Another example, some color and an outlier altogether, some band at the bottom, but it decided this is as close as it could be, so it grouped together this cluster. So we saw from the diagrams that maybe 8 clusters, so we decided to do this, and I'll run through this maybe just as quick through the process of, here's our idea. What you will notice is there's still the outlier, but because we gave it one more cluster or extra clusters to work with, it decided you're on your own. You're nothing like the rest of those documents. Another thing that I'll pull, why? Why are the pink ones there? I don't know, they're right in the middle of the orange ones, but there was some reason as the algorithm was running through, starting the process, it decided, yeah, there's a little tiny cluster in the middle of all those that are unique.
Is there any reason? I mean, I guess in my mind, you have like 2 dimensions you could have affected. You went here, you said, we have 2 principal components and we've done clustering off them. And then you decided to add some clusters. Did you ever think to add some components? Say we'll do 3 PCs or something.
We did a little experimentation, and it wasn't significant enough to say that.
Which makes sense based on the previous chart too. Right?
Yeah. Yep. Exactly. So, but I was interested, and then quite honestly, I wanted to play around to see if there's any difference and what happens if we create a different dimensional view of this data as well, playing around. So a 3-dimensional view just to see what it looked like.
Yeah, those are always the fun.
Yeah, exactly. And that was more selfish for fun rather than something.
Just for those of you trying to get into data science, people like graphs. Question?
Your graph had like 40 things.
Yeah.
That it narrowed down until it got really small.
Yep.
So when you had like a big variation in color, was that part of the algorithm?
Yeah, so we kept with those first 2 clusters in the first 2 principal components. So the tall end, the left side, we ignored everything to the right of those components. And then really it was just using those 2 components, how many clusters were the right amount of clusters to work with. And again, for us, we were looking for good enough, not perfect, because it's not life or death type situation. Cancer or not cancer. It's just, does this document kind of look okay? And I guess the other thing that always happens with this is, for us, it's not a one-time thing. This is very iterative. And so even with service providers that you work with, your monthly bill probably stays the same a bunch, and then they upgrade some software, and now all of a sudden they have this cool new design for you. But it's only when they change that design do you have to worry about, hey, where's the amount I owe? I don't know where they put it now. I was used to looking in the upper right corner. So for us, it's not changing very often, but what we are allowed to do and what we fully expect is the model's going to always be improving. So we have the great fortune to be able to take real-time data as customers are using, get feedback, and then take that feedback and introduce it back into the model. So if we find a document that did not perform well, wasn't able to classify what type of document or wasn't able to pull the right fields out, we can just flag that document and put it back in for training or for analysis, but then back into the training to improve the model. So it's a living, breathing thing that's always improving based on its usage and the feedback that we get. So for us, the answer is really good enough, and we're going to improve it as we see real-world examples, because in this case, we are looking at real-world data, but it is dated, and we're just pulling out of the repository, where some of the documents that we may have trained on might be so old that it doesn't matter anymore. They're not used, and we're seeing new types of documents that are more important. So with this, I'll run through this quickly. So in this case, it clustered a lot of the same type documents together real closely, so cool on that. Another cluster, but it missed on like a couple of these 4, but I'd be willing to bet if we happen to look at the chart and identify the dot on the cluster chart, we'd probably find those real close to the previous cluster that we had. And for whatever reason, as the algorithm was going through, it happened to be closer to, again, the centroid or the point that it pulled together to start looking at the distances. This one, it decided it deserves its own. Another one, some colors, but 3 here. Another group that looks similar, you could kind of eyeball that and say, I can see why you'd group those together. Nice watermark in the middle, maybe a little bit of border. That one that we pointed out that was the oddball, it decided, yes, you are the outlier and you're going to get your own cluster. 2 of the exact same looking documents, it decided, yep, perfect. You're so unique, you get your own cluster. And again, it's because we expanded the number of clusters that we could work with. And then yet another unique one, it's unique from color as well as landscape. Maybe that was the only green landscape document and it felt like it could stand on its own. Yes?
I feel like you kind of already answered this. So it's going based on color and style, borders, things like that. Is it all going on content, verbiage?
Yeah, in this case, not at all. Now, what it may be doing indirectly, so it understands nothing about the text itself, like you would read it and understand it, but it does understand contrasts. So if you think of the document itself, if it's a black and white document, black being where it's written, where things are written, there's big contrast between those spaces. And so if it saw a clump of writing over here in the corner and lots of white space, and then it finds the next document with lots, it's going to group those together potentially. And so that's where it does pay attention to the content, but not to the words or anything from a understanding of what it is, what the actual text is.
Why did you get and maybe that's obvious, I don't know. To me, it seems obvious that to classify documents, content of text would be more accurate.
But remember, we're not classifying yet. So what we're doing right now is trying to figure out what documents to use for our classifier. And so part of that is, so we're just trying to find the training data, essentially, is what we're working on now. And so when you're working with an AI model, you want diversity. So you want as much variety as you can of what you might deal with. You want good distribution within the documents you start pulling. And then for us, maybe not spoken to, or maybe you wouldn't see this always, and probably you would in a way that I didn't understand. But to me, I think of it as what's real world data? How reasonable or applicable is this data? Am I dealing with some old stuff that I'm never going to see again? So we were looking for something that was representative of the data that we might be receiving as well. And so all this is going to do is add up to then allow us to build a classifier. And so there's really several techniques to build classifiers. One, just looking at the look and feel and grouping things together, very similar to the cluster analysis, and saying anything that was in the blue cluster or the yellow cluster, it's this type document. And it can be very much used for that. But for us, we're using two techniques. One, just looking at, once we've grouped together, here's all the types of a good representative set and a good distributed set when we build our model to represent an invoice or a W-2 form. And then the second aspect is you could do exactly what you talked about. And some of those are some of the newer techniques that people are using with large language models, is not only pulling the text, which you've been able to do forever, so OCR it, but making sense of what that text is. And that is one of the new techniques. And so many of the companies that are doing this in a much mature way, mature being they've been at it longer than what we've done, they use kind of an ensemble model. So they'll do it the old way and the new way, kind of group things together, take the best of what they're doing to get the right answer. And we fully expect to do the same.
But also, I think in this case, when we're doing the clustering, it's already one type of document. We're not doing it across many types of documents. So we're looking at, let's say, all the driver's licenses. And we're looking at just driver's licenses. So for example, South Carolina driver's license may have text in different spots than, Missouri one or whatever, European one of some sort. So that's where I think your question sort of, let's say if you have a mix of documents, you may care more about the content, but if you're just looking at driver's licenses, you don't want to just get California ones that have fields in specific.
In this case, and for the documents, for that repository, all those millions of documents, we were fortunate that they were labeled. And by label, as far as type, we knew we could pull 1 million invoice examples if we wanted to, or 1 million W-2 examples. And so we at least knew the document type up front. But in real world, a user is in their email application, they have an attachment, and they want to push it to the system. We don't know what that attachment is. And so our classification model does exactly that. Based on all this training data, we take that document, based on all these examples across all the document types, we make a guess, or the model makes a prediction of what document type it is with some confidence associated with it.
I think a key aspect too to keep in mind for this problem, this is not the problem we talk about a lot in data science, that in Gizmo's case, they have a lot of data, right? So you have millions of examples. So now you're starting to worry about, am I getting representative and balanced data sets? Whereas a lot of times I think in data science, we're always like, I wish I had more data, and how do I stretch it out? But in this case, you're worried, well, let's say I have 10,000 examples of AT&T bills, right, in this data set. Yes, the classifier would be very good at picking out phone bills because that's a phone bill. But if I only have one example of like a singular wireless bill, how do I make sure that I get good representations of that so that when we see the one singular wireless bill, it doesn't get misclassified? And so part of this process is setting up, this is a big thing that I think is difficult in data science, is setting up automated pipelines that you can help you rebalance your data sets when you have such an abundance of data, which is not always a problem in data science. Yeah. It's kind of like a luxury, almost like a luxury problem.
Right?
Oh, poor Chuck, he has too much data. but it becomes, it's another problem, right?
Yep.
This is a really cool, like this work.
And that's still to your question, I think it still ultimately comes down to, here's a problem that I have in front of me, and finding the right tool that's going to solve that problem, because there may be different things based on, so in this particular case, it was this problem, so that's the tool was used, but if you were doing, if the problem was different, you would at a high level.
Yep. Okay, so Gizmo's super excited and satisfied with his with the results. There's enough there that we know how to start. Actually work, but our problem is we're still working with test data. We don't know what's going on with real world examples. Yes, the documents were real world, but we haven't had a user. Everything works until a user touches it, if you've ever worked in software. As soon as a user, they do crazy things that you never anticipated. And so, how will it turn out? Are we going to take off, or are we going to crash and burn? It's really, the jury's still out. We aren't in production with this. Gizmo has not been released to the world yet. So I suspect it'll be another talk, and you'll need to stay tuned to find out what's going on. To be continued.
Is that the last? There's nothing worse than clapping somebody off stage. And that's the midpoint. Are there any questions?
Based off of like what AI has figured out how to track stuff like that, using it, how you can give it a whole story and say summarize this for me. Is there no way with it being classified to upload words to say sort it better?
I think.
Because of that classification, maybe repeat the question. Using outside
Yeah, I think, thanks for that. Out of practice. Yeah. So really the question is, can you use the content of the document to help classify or sort it for you? And absolutely you can. And you can test this with ChatGPT today, either depending on what you have licensed, upload a document to it and ask it what type of document it is. It's amazing without any of your training how it can identify things right off. So absolutely you can do that, and it is an approach. The question is, do we have to use that? Or for us, what we anticipate is blending that technique with this traditional approach and seeing what wins out. So you almost end up voting back and forth. Did you both agree that this is an invoice? Nope, I thought it was a receipt. Okay, great. Now what do? In some cases, you bring in another model to help decide and be a tiebreaker in that. So you end up with a voting type system. Or you blend those together, and Tad probably can speak a lot more to the techniques. He has a more practical experience in many cases with very unique problems. Absolutely, and speed is a consideration in this particular case, because really our use case is a user has a document and they need to put it in another system. Part of putting it in another system is, one, identifying the type of document it is, which we spent some time here, and the next is it extracts information off that invoice so the user doesn't have to manually key it in. So it's pulling that data off. And so if interested at some point, once we get some of the real world feedback, we can certainly jump into that to explain what was good and bad about that.
Yep. Another question, just use the mic so that the many users online will hear you.
Okay, yay. And it wasn't that good of a question. So is it fair to say that you're kind of using like this technique with the RGB and everything to like give it an extra variable to make sure that it's correct, so it's not just going based on text?
You've got it exactly right. It's just one more dimension. And as you saw some of the grouping, it created clusters based on the color in some cases. So it was again, I don't know the principal component, that one, the two really variables we use to do that. I don't know how it determined those variables, but I can look at the result in this case and say, I bet color impacted that.
So it's just giving it an extra
Another
aspect to look at to make
exactly.
sure that it's okay.
And so what's interesting though, in this case, color was important for us to work with. In other problems around documents, the first thing you do is you take away all the color.
Right.
So when you're doing OCR, for instance, so that's optical character recognition, taking text off a document itself, the first thing you do is you take away all the color, because that's just noise. You want a black and white document that's nice contrast between things so that you're able to understand. So again, a lot of it, one is the problem you're trying to solve, and then the results that you're getting. If the results are terrible, crap, we better try something else and get back into the toolbox and consult with Lana and Hannah to help us understand other techniques, or even Tad.
You want? Oh, you have a question. Oh, I was going
to elaborate a little bit too. Just to elaborate on some of this, because I see where y'all are coming from, and I did a lot of work in the previous startup. We did a lot of OCR, and we either would take the text out of PDFs or OCR PDFs and take text out of them. So when we're talking about invoices, a lot of what you're thinking is absolutely right. That hey, just why don't you just take the text? And that's true, except that what you'll find is a lot of times you'll end up getting things like statements thrown in there, which will have invoice written 5 times on it. So now if you're just looking at OCR and looking for the word invoice, all of a sudden you're pulling in statements. And if the receipt happened to say invoice number, blah, 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 then you're pulling in receipts. And the thing is, by also looking at it visually, you're able to do a secondary classification that improves the chance that you're actually pulling an invoice, not a thing that just happens to be related to the invoice, like a collections letter that says your invoice 1565 is 90 days late. And all of a sudden you're treating that like an invoice, but really it's a collections letter. And so that's why you're looking for additional ways to classify these types of documents so that you get a more accurate picture of I'm just pulling things that are due for payment at this point. And so that's kind of one of the reasons why you're then looking at different ways to classify it than just looking at text. Because I ran into the same thing when I was doing, in that case, I was looking at city council agendas and minutes, right? And so you'll have a thing that's minutes that says it's, that it's referring to the agenda. Well, so I can't just look at agenda. And of course, the agenda itself has things where they're approving the minutes. So I can't just look at the word minutes, right? I have to look at various other things. And some of that can be text clustering and things like that, but also visually that can help you.
Great aim.
The first,
For those online who don't know what
work
just
comp
happened,
claim that
Tad threw
we
the
have to
mic at
file.
me and successfully hit me right in the face. And so my question is to when this was, is because I'm not familiar with this space, but if I was presented with the problem of building a document classification system for Legacy Corp or whatever they're called today, my instinct would be to get the latest open weight multimodal LLM and pipe each document into it and say, return just the document type, or here's a list of types of document that I want this to be classified, return only one word, which is one of these types, and basically let the multimodal LLM do that, where it's got basically I guess it's got both the visual element of the document and the text, because it recognizes the text in that. So to me, that's like the best of both combined, and they're very good at doing that in my experience. So what's the downside of doing that is what I'm getting at.
So a couple things. Speed. So for us, we've got a user on the line waiting and being able to process that. Many of these documents are many, many, many pages that we're sorting through, pulling content off those. The other, and again, it's a great tool, and to me, it's just one more tool in the toolbox to be able to work from it. But I will say that was the first thing that we tried. Do we have to do it the old-fashioned way, I'll say, the tried and true way? We found at the time that the models weren't as good as the old tried and true way, the LLM models themselves. We've tried the latest from OpenAI, still not as good as the models and the results that we're getting with this tried and true method. But I don't disagree. Those are going to keep on getting better. And to me, ultimately, what we're going to end up doing is both. And with that, you could imagine sending in an invoice, at least the data, and then just being able to query it. And many of the tools that start use this really, and these are tried and true tools that are out there, cloud services, what you'll see is them really creating a prompt, not only giving them the data in the tried and true way, but you're giving it a prompt and say, tell me the invoice number, tell me the invoice date. And then that's how it's doing the extraction itself. And I'm sure with these fancier models, they're comparing that against the tried and true versus this with an LLM. How much did it match? What are we going to work with?
Can I ask a
Keep it
follow-up?
coming.
At one point in your
And feel free to continue to challenge. I mean, so to me, the cool thing about data science is there isn't a right answer. I mean, to me, maybe Tad may argue differently. But and so the neat thing about it is, how do I think about solving the problem? Try it, and if it works, great. If you're not getting other results, ask somebody else or try the next thing and see how it works. But I mean, to me, there's not a right answer. It's just keep on trying and see if you can get the results that you were hoping for, and then be able to prove that the results are consistent to what you're expecting.
Yeah, and that makes sense. And I don't further challenge. I have a question about one other bit. So at one point, it sounded like you were implementing reinforcement learning with human feedback, basically, of
Yeah, absolutely.
Kind of, going back in, this document wasn't classified right, correct? Can you tell me how you implement that? Like, what tooling are you using, or was Gizmo using to implement that feedback loop and actually to go back into your model?
Yeah, so what we haven't, we're doing this manually by hand as we're building these models. And so what we end up doing through the process is we take, so anytime you're working with a data science problem, first you get this data set, your training data, you split that training data, usually a 70-30 or an 80-20 split, 80 being what you're training on, 20 what you're testing with. And so for us, what we end up doing is after we've built the model, we take the testing data, run it against, is it giving us the results? No, it's not. Crap, what do? What makes this document different than the cluster or the group of documents we have? We compare it to that, and then we run that whole cycle again to try to find another document that looks like our testing document that did not perform well. And then we take that, we rebuild the model, retest, awesome, we got a better result on that document. And so it's very, very iterative where Gizmo here is living and breathing, always changing, always improving. Now in production, we may do that, but what we have are real live documents coming at us from our customers. We also can instrument the UI to see where we might have, in the drop down, for instance, we said this is an invoice. And the user changes it, no, this is a receipt or a statement. We can track that and then flag that document where we predicted something, the user corrected it for us, flag that document, and then send it back either automatically. I think there is a pipeline that we can build, and so much of data science is building these pipelines to automate the process. But worst case, our human in the loop is the end user. They're the ones that's telling us whether this is working or not. And we can mark that, pull another document, retrain the model, and keep on watching. So it's completely iterative through this process.
So how frequently are you retraining the model to take that into account?
I think a lot of times, we haven't done, I mean, for us right now, as we're building the model, it's 20 times a day as we're working through things. Okay. In production, I think we'll find the cadence of what works. And a lot of it'll be the performance of what we're doing. But really, the only thing that will slow us down is the cost of training models, quite honestly. And so it'll be up to old-fashioned ink to decide this model's performing good enough. Once a month we need to retrain it, or we really need to improve this and we can train it hourly if they want to, based on millions of or hundreds of thousands of users and millions of documents going into the system throughout a week or a month. Tad, I don't know whether, I mean, you've got some good use cases of how often you are training models.
No, it's like, till the user complains, like till somebody complains, and then we go do more work, right? I think I have in the past. Oh, sorry, yeah, no, I'm being the bad. You could have just thrown it at me. I deserved it. I hit like, in the past, I've done stuff like where we'll set a statistic, like we'll do residual analysis. And residual analysis is looking at how well the model's performing against like real world results. And if we see the residual go past the threshold, it'll like trigger either a retraining or at least a data scientist to look at it again. But it's, I personally have never used a specific tool for that. I will tell you, if you're really interested, there is a tool called Dispy specifically for LLMs that kind of automatically regenerates your prompt engineering to try and improve results. So in the really large world of LLMs, there's some ready-made pipelines. I'm sure PyCarrot, which is an AutoML pipeline, probably has some sort of reiteration thing. But yeah, I wouldn't say that in my experience that there's any like hard and fast when do we retrain it. Very much depends on the customer and the criticality of what we're doing.
So Chuck, that was a great presentation, by the way. I really appreciate it. As somebody who does a lot of data science, it's like, that's good. So just by way of context and also for my own clarification, if you look at sort of the trajectory, right? We started out with data science, and then we went to machine learning, right? And technically AI came in the 80s before that, but we'll ignore that because none of that stuff worked very well. So where it seems like you're at is you did the data science work, and then you applied the machine learning tools. The only one I didn't see is SVM, which makes me cry because it's my favorite. But what everyone seems to be pointing at, unfortunately, is the AI piece, right? And the AI piece is actually dividable into different segments. The new hotness is LLMs, right? It's actually looking at text because we can relate directly to that, right? But in the data science world, you're looking at similarity of documents from visual face because it has a as Carl did a great outline. I thought of you think you can look at documents and read them, huh? And if you talk to the guys at Hank AI, for example, like what they're doing,
Sure.
you need to know where things are on a page.
Yep.
Like the fact that it appears there is completely irrelevant. What it says is irrelevant. The values are irrelevant, but the location on that document matters a lot. And then there's also where if you have more complex sets, where things appear in the sequence of documents.
Sure.
So just moving a document to 8 versus 10 makes a big difference in how you interpret it. But it looks like where you're at right now is just in training sort of the machine learning side of things, right? And then your next step is the AI stuff where you're going to integrate, say, not necessarily LLMs, but neural nets, because it looks like you don't even need a neural net to do the bulk of the good work here, right?
Well, the real work, the model, the end result of the model is a convolutional neural network that's pulling this out. So it is so the one thing that I'll say, and you can kick me, data science, machine learning, AI, I think of it as math. It's just different algorithms that are doing it. And so I don't get caught up in the marketing. I'm an AI specialist. I'm a machine. No, you're data science. You're just using mathematical algorithms to solve problems. But Tad had a good slide, I think, the other day or your first talk where you had kind of outlined what's different or how he categorized.
Let me be clear, it's how I.
And so with that, the point that I'm making is everybody will say, so for our customer, we are doing AI.
Right.
Because it's important for them in the market. We're cool like everybody else. We're doing AI. But to me, it's math.
Yeah.
And they're just cool algorithms.
Yeah, if you're using convnets, that you're definitely in the AI space. You're just not necessarily LLM space. I don't think convets work as well for language as what they're using now.
You can do it. It's like
well, that's not the
variation auto. That's the flavor.
Right,
That's the
right.
flavor for the
Right.
But I went on editorial comment on the differences of what you're calling this more from.
Yeah.
So, so you can look at the researchers in the world. Jan LeCun says, if you're spending time with LLMs, you're wasting your time.
Right.
Because that's like an exit ramp to where things are going. You're completely wasting your time if you're spending any time working with them, using them, because there's better stuff. And a little bit of this is tied to the researchers and getting them not to be so much focused on that or improving or working with it. Because his opinion is it's a tangent. It's not where things should be going.
Well, yeah, and I think that the weakness of LLMs in particular, and you see this, they have prompt engineers. Where did that come from? If the LLM's so smart, why do you need an engineer in front of it? But it's the data science piece, right, and the machine learning piece that provides the framework, right, that is the pre-prompt engineering, well, in this case, pre-training data, right, that allows you to do the training for the convolutional neural network, right? So it's part of all this pipeline piece. And to your point, you can add other things on it. You can do ensemble. And then add on top of that, right? Sure. But you're very much like right in the middle of this, from what I see, right? Like right in the pivot point of you'll have a product just by the end of, or Gizmo will have a product by the end of what he's doing.
Gizmo is the product.
Gizmo is the product, right? But there's opportunity there to layer more sophistication on top, whenever you're
absolutely
ready.
Yeah. And just like anything, you're always looking to improve. You're always paying attention to what's out there and how that new technology, new algorithm, new large language model, how it applies to your business problem. And to me, where I mentioned one of Tad's early questions, I don't know how you can be in this field and not keep up with every list that you can come up with or anything else, just to keep up with, hey, there's this new technique. Wait a minute, can I use that for my problem? Did you have something to add?
No, I was waiting for you. You're
Yeah.
crushing. I was just gonna say. I mean, we were gonna kind of wrap it here. It's just 7:45. So, but obviously Chuck's still around. You can harass him
Absolutely.
with any questions you want. He's easy to find. We get another round of applause for Chuck. We have had a lot of data science presentations, but don't let that intimidate you. If you have another technical topic you want to talk about, we are open to that. This has been like a really good, for those of you who have been to like all of them, I think you'll see like a really cool transition. I gave a talk about explainability in AI and some of the traditional machine learning models. The honest talk